So I just introduced myself. I was talking about definitions of knowledge, the varying definitions of knowledge that we've seen here at the conference that are brought across the NLP community. This is a very general definition. We're going to be focused on different types of knowledge for this talk. And what we see from various presentations here in this workshop and earlier in the conference is that if we incorporate knowledge from documents, from knowledge bases, we can have much more effective and engaging conversations across the very diverse topics. And the clicker does not work. Wait, try again. Try turning it off and on again. I have animations, okay. So I want to start by giving you a little bit of history. This is work that I did with a collaborator, Neil Lathia at Monzo. Monzo is a leading startup bank. And so I wanted to give you an example of knowledge being deployed in the real world, because that's an element of my work, kind of applied work, as well as kind of theoretical foundations. And so this was trying to scale Monzo support, going from a small little bank to having millions of customers worldwide. And really this goal here was to help customers help themselves. This is accessed by using the in-app chat that if you have Monzo, this is how you access customer support. And this was a project that focused on retrieval. So Monzo has all of their knowledge for customer support that's shared on their website, and you can retrieve it. And so this was a very early example where we focused on developing a ranking corpora, where we were actually able to direct people to the relevant information. And just this single element alone was able to significantly reduce the cost and time that actual customer support representatives were able to use. This doesn't go into question answering. It didn't go into much more advanced elements that we might expect, but it was very effective. Where it wasn't effective is when the question was wrong. There were whole classes where the question that the user had was underspecified. It required interaction to actually be able to elicit and talk with the human to be able to gather the right information, but then probably the answer was still in the knowledge base. And so that was an element of the fact that we need mixed initiative and clarifying questions to be able to do better. So this was just an early work, and the search systems that we have evolved fairly far from this, and we'll see how that's evolved in this talk. I'm going to be talking about three kind of core cross-cutting challenges that are going to cut through my talk. So the first one is on grounding. So this is in the previous talk, we talked about grounding information to vision, information to knowledge bases. And really that's exactly the case in my talk as well. It could be text, it could be images, it could be a knowledge base. But while we think this is solved, actually in practice, if we're using this in conversational systems, it's actually a really common failure case. And that actually is still a fundamental challenge that needs to be addressed and we need to do better about. Second is the discourse structure. This is the structure of the information and the knowledge that we're actually going to be using in our conversation. Very often we either deal with text or highly structured information, and we actually have to leverage and understand that structure to be able to use it effectively. We think there are hints about doing this already, but they're often disconnected. So we either talk about tables or we talk about text, and they need to kind of come together in order to be able to be used effectively in conversations. And then something I'm going to call coherence. So this is about guiding a user through the knowledge process, through a trajectory, not just giving them an answer, but also guiding them to, and also you might want to know this. It's not just about that trip to Mexico and what the fees are, but also other information and anticipating what they're going to be asking next and informing them in a knowledge grounded and guided way. We're going to be looking at, there are three parts to my talk that are focused around three separate tasks where we're going to see these challenges unfold. The first is the TREC Conversational Assistance Track, TRECcast.ai. It's one of the leading benchmarks in conversational search. I'll be talking about that in a fair bit of detail. The second one is a new bit of work called Wizard of the BBC, kind of affectionately kind of named after some of the other kind of dialogue benchmarks that you may have heard of. And that's a collaboration with the BBC and BBC Voice and AI group. And lastly, I'll be talking about some of the ongoing work that my group is doing in the Alexa Challenge as part of the kind of robot and task-oriented systems. And we're currently in the finals, so that's quite exciting. So I'm going to be now talk about the web as knowledge. And so this is conversational search, interaction with web scale knowledge, text information from the web, and doing so in a conversational way. So imagine going to Google and instead of having a search box, you have a chat box, and the documents and interactions that you're doing, understand the documents and be able to interact and converse with them in a meaningful way. So this is kind of this is that setup. A person might come. How does investment work for startups? They're going to do conversational search. There's going to be information, text information or knowledge kind of retrieved from that. And then interactive, it's going to evolve. We'll see, I'll show you an example. The core task here is ranking. So this is a ranking task. The goal of CAST is to develop a reusable benchmark for conversational search. And NIST has a long history of creating reusable benchmarks, and that's really what we're trying to do fundamentally. These are also real information needs. This is work with Microsoft and Jamie Callan from Carnegie Mellon. And these are information seeking needs from Bing users, long exploratory sessions. And so that kind of differentiates CAST from some of the other benchmarks that don't have real user information needs, or they're synthetic from documents. So we have real trajectories, real kind of sessions that kind of form the basis for these conversations. So this is an example of a CAST kind of year topic, type year 3, if we had topics, which maybe we don't, which we'll see in a minute. So this is about genetics and gene editing. So the goal is to explore the information about a topic, complex topic, that spans multiple documents. Here's 3 different Wikipedia pages, but it might be hundreds or thousands of different documents that span all the different aspects of genetic engineering. And so in CAST, this unfolds through a conversation that a user is going to have with the search engine, the hypothetical search engine that can understand these conversations. And it might go with, how do genes work? And the goal in this case is to rank candidate responses. Maybe they're not perfect, but they're candidate information, candidate knowledge that could be used to generate a response. These are kind of long answers, non-factoid answers for the most part. How questions, why questions, so what questions? And so those are very different from the talk that we saw earlier, which are very often very short questions that kind of very often kind of short factoid questions. So what other diseases are caused by a single change? So in this case, we actually see that it's referring to the last sentence in this response. So it depends upon the response, it depends on a long answer response, which makes it challenging for existing neural systems. In this case, we actually have a list from a document, a very good document that gives an overview of human genetic diseases. And there are 4 types. It talks about the first one, monogenetic diseases, as well as talks about the cystic fibrosis, Huntington's disease, and other diseases that are within it. And so the user asks, okay, great. So what are the other diseases that are there? You might expect the next thing to do would be to understand the document structure and to provide the information. But that's not the case, because these systems usually don't have a model of discourse structure. And so what we see is that these models fail. In this case, our passage retrieval is actually pretty intelligent. We do okay. We get the 3rd thing in the list because our state-of-the-art ranking, neural ranking is relatively robust. But we skipped the 2nd one. So this is chromosomal genetic diseases caused by large DNA molecules. And then you missed the 2nd type of disease. So what was that? In this case, these are providing feedback, saying, I wanted the 2nd one. And the system is not a question, right? So it's feedback and a question. And the system doesn't know what to do. It gets confused effectively and returns information about a related set of passages. So the system needs to be aware of the information of how the user is navigating the structure, how the user is navigating the information space. And we're not very good at that today. And then the user changes the topic. That's not what I wanted. How about some developments in gene therapy to deal with those defects? The conversations, this is the full conversation in CAST. If you look at it, it's kind of a long conversation, about 15 turns that spans multiple different aspects. If you're looking at just the queries, you may not be able to understand the conversation. That's intentional, because you have to understand the knowledge in the responses. You have to understand the search responses of the system in order to be able to actually carry on the conversation in a meaningful way. And within this, we present several different challenges. So obviously, as I talked about, it depends on previous knowledge. The previous responses the system gave to the user matters, and they matter a lot. And they're long answers. So there's sequence reference here. This is kind of discourse structure that the system should be aware of. There's feedback. So that's not what I wanted. That's too basic. No, I meant in humans. So the system should take that response, feedback, adapt, and actually produce relevant results in that case. And very often, that's partially the case. It kind of works, and sometimes it doesn't. And you'll see some cases where it doesn't work. As Siva mentioned, we also have to deal with topic shifts. This has subtopic shift structure, talking about different aspects and subtopics related to gene editing. And very often, if you don't handle these and handle them robustly, the system will also fail, and kind of the rewriters will fail. And we'll see some examples of that. I just wanted to give you a small overview of the results from last year from this. There were 15 teams that competed from around the world. There were over 50 different runs that were submitted. The ones I highlight here in red are the organizers runs, or ones that we organized. Org conv.dr is kind of conversational dense retrieval, building up a representation of the previous context using a dense vector from Microsoft. That was Chenyan's work. And if we rank those vectors, conversational dense retrieval on its own actually performed pretty poorly. These are long vectors. They're fairly compositional. They have a lot of different subtopic structure in them. And so they work okay, but not great. Re-ranking with BERT gets it slightly better, up to above the median now, which is great. But if you look at the kind of the baseline system, so this was the baseline that we had a sparse retrieval T5 query writing, which we'll see an example of in a minute, with mono T5 re-ranking on top. So that's kind of one of the system that is fairly familiar, kind of a standard system. What we see here is that a lot of systems are doing really well, much better than that baseline, which we're great to see. This really represents kind of dynamic fusion, dense retrieval, sparse retrieval, using both of those together, and actually fusing those results together in combination with conversational query expansion and more complex language understanding techniques, which I'm not going to go into detail, but you can read our proceedings, and the details of those runs are available in the TREC proceedings. What I do want to highlight here is the fact that these runs dramatically improve recall. We're up to over previous years. This is now achieving almost 85% recall, as opposed to previous years, which was close to 65. So we're seeing some major gains, major breakthroughs that are starting to happen in this space, which is quite exciting to see. But we still have a long way. Oh, and this is doing sentiment analysis, trying to identify feedback. And so we're starting to see actually, if you're actually able to identify those topic shifts and feedback, you can actually do quite well and better than the median. So I think that's an area for future work that will continue to evolve and improve. So what we see here is the fact that despite this, the T5 model that was the median that we have here, kind of trained on a large query writing data set with hundreds or thousands of tens of thousands of different sample conversations. It does okay, but you actually see here the fact that the grounding, these models typically are not grounded to entities. We did that in the first year, and actually what we found is that everyone switched to neural models and largely ignored the entity linking, the linking aspect, and just counted on the neural rankers to do it automatically for us. Maybe that's not the correct approach, or maybe that's not a fully approach. What we see here is that can go awry. In this case, there's hallucinations. It's hallucinating cystic fibrosis from the input example there as well. And it's also missing different types of context. So types of diseases, it's actually genetic diseases that are being referred to here. So it's getting part of it correct. What that means is that those queries talking about general disease are not going to be relevant because you're going to miss key aspects of the query. And if it's uncertain, there's a bias in these models to not rewrite. So it and that are kind of pronouns and references that should be resolved, need to be resolved, but they're not. And so that leads to catastrophic search failure, which we'll see. And once you get down to some of these elements as well, once it kind of latches onto a concept like CRISPR, which is a very popular concept in this space, it starts to hallucinate and kind of automatically resolve that, and with a strong bias towards popular concepts in ways that are just, these are all wrong. So that's kind of as the conversation has gotten quite deep. So grounding to knowledge can work pretty effectively, but still has issues. So this is looking at the effectiveness of these systems kind of turn by turn over time. Well, not the effectiveness, this is the dependence. So we know what turns depend on previous answers, previous questions, because we organize and develop the structure of these conversations. What we see here is that there's a very strong focus on result dependence, long answer, long dependencies. This is over half the queries have result dependence for this past years, and almost all of them have complex dependencies. These non-trivial dependencies are things that require not just the previous turn or not just the first turn, they require going back in time, looking at previous responses and previous queries from far back in the conversation. So those heuristics that you might have of just appending the last turn or appending the first turn, we're going to break them because these are not good kind of conversational structures. The models need to be more robust to be able to track and handle the knowledge change across time. Maybe this will work. It's turning on. It's right on the. Got it. Okay, it's working. It's right on the edge of that. So this is what we wanted to look at. This is results by conversation depth. So how do the effectiveness of the systems vary as the conversation gets longer? So what we see here, the blue line is the automatic system. And this is the median, all the systems that outperform the median averaged together across all the different runs. And what we see here is that those automatic systems that are using the neural query writing degrade over time, right? So in turn 3, turn 4, there's a 30 to 40% gap between the automatic systems and the manual human. The manual human was a manual human rewrite where we remove the ambiguity kind of from that. It's not the gold query by any stretch of the imagination, but it's just an unambiguous query that had the knowledge automatically added to it where appropriate or needed. And so what this means is that overall, these systems versus what we have here is a knowledge gap. We have this rewriting gap where even a state-of-the-art neural query writer like T5-based models that are commonly used have almost a 30% difference between what the gold standard should be. So this is still a challenging task. There's still headroom here, and the conversations are getting longer and more complex discourse structure that are really pushing the boundaries. This is looking at those failures in a little bit more depth. Some of my students, which you'll see maybe at the end of the presentation, looked at where and how and why T5 and these query writers are failing. So this is work that is under submission. And what we see here up in the left-hand corner in the red box are the cases where there's a large difference between the manual query and the automatically rewritten query, particularly ones that have a bigger gap of 0.4 NDCG. So that's a very large difference in the ranking, like a equivalent of almost catastrophic failure of the query writing. And we see that around turn 4 to turn 8, there's an increased number of these catastrophic failures, and that accounts for the graph that we saw in the last term. And the reasons for that are some of the ones that I just showed you early. You saw an example of that conversation where you saw T5 failing. The CRISPR kind of over-dominated towards the end. It hallucinated some, it missed some, and those are some of the different categories. So omission, overgeneration, relying on initial terms, and others. So I hope to be able to share more about this work when it's published, and there's a lot more depth kind of going into each of these categories in detail. But I wanted to focus on some of the knowledge challenges across the different tasks. So in this case, in CAST, what we've seen is the fact that if we're able to better use knowledge, if we're able to improve our grounding, improving our rewriting, we still have a long way to go to actually, there's a lot of headroom to be able to make that much more effective. We have to improve use of document structure, documents as well as language structure. And what I haven't really talked about here was the fact that this was all largely user-driven. So the user asked questions, the system responded, the user maybe clarified, provide some feedback. There wasn't a lot of opportunity for the system to take initiative. And that's something that we're going to be changing this year. We have a brand new mixed initiative subtask, which is quite exciting, and I'll briefly talk about. And if you want information, it's available, the guidelines are available on the website, which we posted recently. So in the second task that I'm going to be talking about, this is called Wizard of the BBC, kind of knowledge-grounded media exploration. This is some new work that we were doing in partnership with the Voice and AI group based in Glasgow, where I am, just down the street from us, which was quite exciting. And so if you're familiar with the BBC and its mission to inform and provide kind of news and information across the world, what really exciting thing is that they've been very progressive in this. They probably have one of the most popular kind of skills on the BBC, developed specifically for Alexa. It's one of the most kind of complex applications that they have there. And they have a dedicated news team. This is the exciting part. They have dedicated news journalists creating articles and trajectories manually by hand, kind of curating it for a voice experience, much richer than if you just ask Google for the news, right? Because this is actually curated stories with arcs and stories, and you can ask for more with extras and fun facts. And so users are really responding to that weird fun facts, background information about the story and the history in a way that is done. But this problem and this information is curated by editorial staff. It's expensive, it's time consuming, and it's not largely automated. And so to do this, if we're going to try to automate some of this, we want to look at research and how we can scale this. We're going to need to understand the discourse structure to be able to stitch these stories together in sequences, to be able to create these background extra sources of links, to be able to guide the user through a trajectory in a conversation in a meaningful way. So we developed a research prototype built on their BBC, the BBC built a voice assistant called Beeb that we worked with. We developed a multi-year corpus that spans different types of media, news and sounds information, radio programs, podcasts, rich sources of content to be able to discuss and have a conversation about. And we semantically grounded these. So BBC has its own knowledge graph called BBC Things that they have taggers for, that they use editorial. And these are linked to public open source knowledge graphs. The BBC Things KG is also publicly available. So another large scale public knowledge graph. This is an example kind of conversation. This is not crowd workers. These are editorial staff, professional journalists. So the data here that we're collecting is very high quality. It's not crowd workers, and they're very focused on very good high quality conversations, very high quality responses that are in an information seeking context. So in this case, the user is looking for information about the word of the year. The wizard gives a response, and the wizard suggests follow-on about this year's word of the year instead of last year's. So there's coherence where the wizard is guiding the user through to a different aspect of the topic, as well as understanding the discourse. So in the second turn about lockdown of the year of the term of the year in 2020, as we perhaps were familiar with, there's more information in the article that is being suggested by the wizard for the user to read. So as part of this, we're excited to say that we are releasing some of this data and data sets that were used for this Wizard of Oz data collection. We called it COMEX, for Conversational Media Exploration. And it really kind of corresponds to the different elements that we would have in our research prototype of a conversational kind of knowledge grounded agent. That includes grounding, the topic focused entity linking that we have here for our task 1. Conversational passage ranking, corresponding to being able to find the right documents and the right passages to return to the user within them, similar to what we just saw in the cast setup. And then the last aspect is coherence, the entity follow-ons, taking and being able to generate those follow-ons, and being able to find the right entities, the right documents that are connected to them in meaningful ways, and then actually generating a response that doesn't just say give a title of the article, but connects it to the conversation and says how and why the user should go and should read that article and how it's connected. So I'm going to briefly kind of go through some of these tasks and give you an overview and some of the challenges that we see when we try to do this. So again, we Wizard of Oz content, we developed some topics. We developed topics in conjunction with editorial staff. We sampled from that a subset of the documents that were used in those conversations, and we annotated them with professional BBC editorial staff. Like you can see here, information about the Hyperloop and its technology from Elon Musk, which was going on at the time, the competition. And these were editorial labeled by hand with the entities grounded to Wikidata knowledge graph. They're grounded for the individual mentions, not just of named entities, but of the key concepts, because users don't just ask about Elon Musk, they're asking about electric cars or electric vehicles. And so it's effectively Wikification. So in this case, we also include salience information, where the key concepts that are in this article, that are in this passage, is this the important mention? Because that is going to be used to be able to kind of guide the conversation and the follow-ons. And some of the topics may not be explicitly mentioned in the text, but that are editorial topics like cybersecurity, that are extrinsic knowledge that are kind of higher level than just the mentions. So we really wanted to see the kind of how suitable existing state-of-the-art methods were. Hopefully we could just use them off the shelf and plug them into our conversational system and they would work. But what we found was actually that this was a lot harder than we expected it to be. We spent more time working on this than I would have expected. We took two, in this case, the BBC has its own linkers, which I can't really talk about, but I can share experiments with the external ones that we used. So we used two kind of state-of-the-art. This was kind of REL. We did start late. So I'm on time according to my schedule. What we have here is the fact that we have REL and genre, kind of state-of-the-art ones from Radbud and from Facebook. We see that REL is producing fairly high precision, but low recall. And in this case, with the fact that we have genre, has actually pretty low precision, but a higher recall. In both cases, these results, the fact that this grounding process is very noisy. This is almost half the effectiveness of what we see published in the benchmarks. So if you look at those F1 scores, they're around 0.45 or 0.5. And if you look at the published papers, they're at 0.87 or 0.9. So there's a pretty big gap between just kind of taking these off the shelf and using them on these heterogeneous collections. Granted, we have changed the task a little bit because we're actually asking BBC editorial staff what they think the entity should be. I'm going to kind of go over some of this a little bit faster in the context since we started late. There were challenges in passage retrieval. We can't answer all of the questions that users ask. information about drugs, information about if we should get COVID advice, because the BBC can't give you medical advice and they can't give you commercial advice. So in this case, we have to understand what we can answer, what we can't answer, and how and why. And even when we do answer here, the quote is given that we have here about trans people and abuse. It's a quote taken from a third party. It's taken out of context. It's a passage that happens late in the document when the author was introduced right at the start of the document. So even from an editorial perspective, it's quite challenging to be able to link these things together. We have heterogeneous styles across news, different styles of news, and heterogeneous structure coming from podcast structures. If you use these naively out of the box and just kind of retrieve them or just kind of use them in your generative system, you will find that it does not work effectively. We found that, so it requires more work to be able to generate useful responses from them. For the follow-ons, we did a lot of work kind of cleaning up those noisy entities that were detected. We had to put a lot of post-processing on top of it with wording to rank features and salience features on top of it. And here's some examples. For example, a document from Egypt talking about mummies and also finding it compelling the oldest figurative tattoos in the world. Or if about reading, down here on the bottom, that pupils aren't reading enough challenging books. So summer's coming up in kind of summer reading. And so that's coherent. So that's kind of wrapping up the kind of BBC side. So my take-home message here is the fact that it's not enough just to look at the responses. You have to look at all of it in a coherent way, the documents, the knowledge, and have end-to-end evaluation of all of those components. And that's what we kind of strived for in ComX. And we need better methods for grounding, better methods for topic trajectory analysis, and understanding the diversity of the types of legacy kind of text that we have, because they're not suitable for conversational interfaces, voice or even text. I know I'm cognizant that according to me, I have 5 minutes left, but okay. The last part here is the fact that we have the Grillbot. This is in the Alexa Prize Finals. We're in the finals, so we're one of 5 teams competing in the finals. We'll find out how we did in about a month. So this is brand new work that we'll invite me back next year and I'll be able to tell you lots and lots of details about how we did and what worked and what didn't work. This is really exciting because for the first time, Alexa is in your kitchen with a screen, and so it helps you cook along with a recipe or help you build furniture, perhaps for your kid to be able to build a new bed or a new set of environments. So that's trying to make it much more compelling. 1 second. There we go. So this is an example of one of those conversations. You might start out by, what do I want to cook? And as part of this, you would like to search, task search, find apple pies. I have these great recommendations. We want them to be knowledge driven. So it should be seasonal. It should take into account when and how, what's in season right now. Maybe what's on sale at Whole Foods, what's on sale at your local market or your local farmer's market as well, to be able to guide that. That's external knowledge that you can't get just by in a language model, because the world is constantly changing. Those specials are changing. What's seasonal at the farmer's market is changing. The system has to incorporate search and knowledge to be able to incorporate those and do so effectively. And that's right there as well, the justification incorporated into the dialogue. Family apples are in season. And so introducing that as justification for how and why a user should pick this recipe and make it. And then to be able to adapt. So in this case, the person says, that's great, but I don't have butter. Or maybe actually they are dairy free, like one of my PhD students who's working on the challenge, and being able to do dynamic substitution to substitute sunflower oil. Where does that knowledge come from? It comes from search and external knowledge sources as well that we curate for this task. And there's a whole set of different task-based kind of knowledge challenges that is another talk that I can give about these different elements. But they go through the same common threads that I've been talking about. The first is we have to extract and ground information. In this case, it's different. It's ingredients, it's materials, it's tools that you need to perform the task, not just grounding it to Wikidata. And if you can imagine here, if you miss an ingredient or you miss an important tool, like you missed a grill, you can't actually cook a recipe. So it's catastrophic kind of failure of your task. You need to be able to adapt on the fly to perform those material substitutions. Maybe you realize halfway through the task that you're out of something. You need to adapt it in the context of that task and with the user's preferences and constraints. And you need to be able to support rich kind of task question answering as part of it. So what is kosher salt? Maybe you don't know what it is. Maybe you don't have any in the UK. What can I use instead? If you ask GPT-3, what is kosher salt? It says it's salt that's blessed by a rabbi, which I found quite funny. That's almost right. It's used in the koshering process. So it's lacking that knowledge. It kind of hallucinates kind of the elements of koshering, right? And so you can't just use that off the shelf. Even for state-of-the-art GPT-3, massive language models kind of fail. And what was really exciting about this task was the fact that we had task level video and multimedia information that we wanted to include, images and videos. And the clicker stopped working. Next slide. There we go, thank you. And so one of the things that we have with work under submission here is to actually use videos as knowledge. So we curated YouTube videos, short instructional and WikiHow videos of people actually instructing you on fundamental cooking techniques, how to brunoise a carrot or how to chop garlic. And we want to introduce that into the conversation at the right time in a fine-grained way when you're actually performing a step to be able to teach and instruct you. And so we did some user studies. This is deployed in our system as well, so you can try it out. And what we found is that approximately when you actually did this, users actually started to learn and they really found that engaging. So approximately 65% of users, when they saw the videos, they actually learned something new that they hadn't learned before in the cooking process. So that was really quite exciting. And this is done automatically. So we were actually looking at automatic neural methods for doing this linking, but it is noisy. Approximately run 3, 1, 4, the videos are not quite right. And so that's an open challenge there because there's a lot of subtlety in that. And so just to conclude, we looked at different types of diverse forms of knowledge, text, entities, media. We've talked about how the grounding process is really challenging from entity linkers all the way to video across these diverse domains. But really what we see here is the fact that knowledge from these different sources is fundamental to creating compelling experiences that can help people find the right information and also accomplish tasks in the real world. Next slide. So this is my lab, kind of come join us. Find more information. This is work not just from me, but from a whole host of characters from my PhD students, kind of Carlos, the Alexa team lead, and all the others. We open visitors. We have open PhD student positions that are funded, open postdoc positions, and we're also hiring for experienced research engineers. And so please join with us. CAST Year 4 is happening. Please come talk to me about it. Please participate. There's information on our website. Come register. It's quite exciting. We have mixed initiative subtasks that are happening to address the coherence kind of challenges that I've highlighted in this task, where the systems can ask questions, get feedback, and use that to improve the effectiveness of the results. We have new organizers, including some people here. So the information is there, and also I'm happy to answer questions. And if you have questions, you can also kind of direct it to a new addition to my family. So my son, Aiden. So thank you very much. I know we're a little bit over time, but thank you for your patience.